Hello and welcome back. In this lesson we're going to be going over Docker. And Docker is a pretty complex subject, and so we'll probably break this up into a number of different videos. In this one we're just going to cover some of the basics of Docker and what it is and why you'd be interested in it and possibly how to use it. So to start off with Docker, what I want to discuss a little bit is what we had before we had Docker, and that would kind of lead up to the reasons of why you'd possibly want to use Docker and such. So if you could for a second kind of imagine back to the good old days when we just had operating systems and they just ran on a computer and that was it. Well, let's say you were a Windows fan and you had Windows on your computer. If you ever wanted to try out some of the Linux open source tools or GNU compiler or anything like that, what you had to do is either you had to have a separate computer or you had to dual boot your computer. So partition your hard drive so that it has an entire Windows partition and an entire Linux partition on it, and then when you had to switch between it, you had to reboot your computer. You had to hit the delete key or something on the startup and select your different operating system. Then you fast forward a few years, and then virtualization became kind of really awesome. So you could now run as a host, like say Windows. You could run a tool such as VirtualBox, and let me kind of open up a picture of VirtualBox running on. In this case, it could run in multiple different programs. So VirtualBox in this case is running in Ubuntu, and you can kind of see here you can emulate and run Windows 95, 98, 2000, whatever, Red Hat, Oracle. So you could actually have tons of different operating systems that you could just power on, turn off. You had controls that you could go into and enable whether you wanted to have a video capture devices or whether you wanted how many CPUs you wanted it to use. Basically, you could kind of scale those things down and adjust it. How much RAM. And fun fact, this is essentially kind of the hypervisor they kind of use on Linode. If you think about it, when you rent a 1 CPU, 1 gig of RAM nanode from Linode, it's not like you're actually getting an entire server that just has 1 CPU on it. No, what they're doing is they're just essentially running a virtual machine that you maintain and manage. And whenever, say, you want to upgrade that from 1 CPU to 2 CPU and pay the doubling in price from a Linode, all they're doing is they're essentially going in programmatically, mind you, into the general settings of that hypervisor and saying, oh, instead of 1 CPU, you now get 2 CPUs, and they start charging you extra. So VirtualBox and virtual machines and hypervisors and all the different versions of it were really powerful tools, but they kind of came with a lot of extra overhead. Some of the things that you're trying to solve when you're trying to do virtualizing is you just really want your program to be kind of self-contained, or your execution to kind of have its own contained area where if you wrote to the wrong files and messed stuff up, it didn't really matter. You could just kind of blow it away and start again. Or if you wanted to just have the bare minimum of what your application needed to run, you'd have to have an entire operating system running. And so entire operating systems with GUIs or whatnot would have been kind of what you would set up. And as you can kind of see over here, most of these things are powered off. So all the Windows 95 and 2000 and all that stuff, they're powered off because they'll take up resources. But it would be nice if you could just run software and programs that are essentially self-contained in their own little sandboxes, but they don't have all the extra overhead of an entire operating system with them. And so that's kind of where Docker came in. And let me pull up this picture here. Docker, when you compare it, so over here we kind of have the virtual machines or virtual boxes. You'd have your infrastructure, your actual physical hardware. You'd have a hypervisor which would be running, which would be VirtualBox in that picture that I just showed. And then you'd have your entire virtual machine, they would call it, with your guest operating system, and then your application on that. And so if you wanted to have another self-contained one, you'd have app B with its guest operating system, kind of C, and all that kind of stuff. What Docker did was, and just kind of containers in general, did was kind of the same, where you'd have a host operating system, but then you'd have the Docker engine that's running across it, and then you can just have these kind of containerized applications, A, B, C, D, E, F, whatever, and you don't have all the extra kind of overhead of the guest operating system. Docker itself will insulate each one of these containers. They'll have their own file system, which just maps to a single file on the hard drive of the host operating system. And so the nice thing about that is you can configure it so that it grows and it can expand out to your host operating system. You're not necessarily having to allocate one CPU to this guy, one CPU to that guy. They can kind of share the resources across it. And it's just very powerful to be able to do that thing. In fact, so much so that I honestly look, when I'm installing pieces of software onto my host operating system, especially in a Linux server environment, I typically look for a Dockerized container of that same software, because it just has everything that you need in it to get going. Whereas, let's say you're installing Nginx or something like that, you'd have to install Nginx, but then you have to install the libraries that is required. You have to install some other stuff. You have to go in and modify some configuration files. Whereas it almost feels like a container for that application is kind of a obviously contained application that has everything that you need to go right out of the box, and it just runs fast, as you'll see here in a second as we pull that up. So when you think of Docker, and the reason why they kind of call it, you think of these huge container ships that where your host operating system is this big kind of massive ship, and you just have lots of these self-contained, they're not spilling into each other, containers that are sitting on it, and hence kind of Docker name that came out. Well, what I want to do now for kind of the rest of this video is kind of go over some simple uses of Docker. So the first thing, obviously, you have to get kind of Docker installed, and I'm not going to go necessarily over that, but it's Docker has pretty good instructions on how to do it for whatever your host operating system is. As we're using Windows, I've got Windows subsystem for Linux with Ubuntu running on it, and so I can just kind of follow the instructions here. And essentially, it just boils down to it's doing an apt update to update your repository packages, and then installing these standard packages, which most of them will probably already be on your computer, such as curl and stuff. Next step would be to run the curl command that would add the Docker key into your Ubuntu key ring, and then setting up the sources for where they can pull that Docker image, and then finally you actually update one more time with all this new information, your repository images, and then finally install Docker CE command line, and container IO. So I've done that already, and now we're just kind of starting with a fresh Docker terminal, that we have here. Also, one thing I will say real quick is that with Windows, and I've also seen this in Mac, there is a Docker desktop application that runs and kind of communicates with the Windows subsystem for Linux, or the Docker engine that you have running, and you can kind of see what containers you're running. So right now you can see, hey, there's no containers running, so we're going to go and fix that problem right now. So the very first one that we can just run is kind of their hello world. It's a very simple Docker image, and I'm just going to run it, and then we'll explain kind of what happened here in just a second. So I'm going to say Docker run hello world, and it first complains, hey, I wasn't able to find this image locally, and so now it's going to go out and communicate to the web, and It'll pull down that image. It has, some SHA hash of what the image was, download a newer image, and then all this hello world did was print out this message right here, and then it actually exited. So if I type Docker PS to list kind of the images that are currently running, I get nothing. And if we go back to our Docker Hub or Docker Desktop, you can see that it has this hello world here, but it says it's exited. But you've noticed in the command line you don't see that at all. That's because by default Docker PS just shows the currently running instances. If you want to see them all, whether they're running or stopped, you do a -A for all. And there you can see that there's an image called hello world. The command it ran, how long ago it was created, the current status is that it exited 47 seconds ago. There's no ports mapped to that, and we'll talk through that in a second. And then it gave it this weird name, this ecstatic Snyder. And that's because when we ran it, we didn't give it a name for it. So by default, it won't choose the image name that you downloaded for the name of your container. It just chooses this random string of words that it puts together, kind of thing. What I want to do now is I just want to show a quick image of kind of what happened there. So here we go. So essentially, on your host machine, you'll have these containers that run, and they're run off of what are images. So if we go kind of up this chain real quick, out there in Docker, there is a global repository that Docker.com and the Docker company kind of manages of all these images. Think of it kind of like NPM, where there's these kind of packages out there that you can install via your package manager with NPM. Docker does the same, where there's these images that are in the registry. They're stored up there as static files. When you do a Docker run, what it does is it'll pull down those images, and they store those images persistently on your computer in as Docker images. And then when you run that, it'll take one of those images, clone it, and essentially start that container. So you're not actually messing around with the actual images. You've cloned it and created your own copy. And again, this whole section is on your desktop of that. And we can kind of see that in the Docker desktop application. If we click on images here, I see that there's that hello world. It's currently in use because there's a container running or stopped with it. The image ID, the last time it was updated or modified, and then the size of it that it takes up in space. If we go back to the containers here, we can see there's the ecstatic Snyder, the hello world, and all that. So what I'm going to do here is I'm going to show you how to remove a container. So we would say Docker RM, and we would say the ecstatic, and you can normally tab complete these guys. So hit tab and it completes. And so there we removed it. If we go back to Docker desktop, we have no containers there. However, if you actually look at our images, it actually still has that hello world cache right there. So if you want to kind of clear up your hard drive and save, in this case, a very little bit of space, you could actually remove those images. I believe it's Docker images, image RM, and then hello world, and you hit enter. It says it's deleted, and now the images is actually out of there. Okay, so the next thing I want to do is do something a little bit more advanced than hello world. Let's go ahead and, in this case, instead of running it immediately, I'm just going to actually pull an image down from the registry. So I'm going to say Docker pull busy box. It's pulling the latest version from library busybox. We have it. It says, hey, downloaded one. And now we have that right there. If I come here, again, I didn't run any containers. I just pulled an image, and we come to our images. We see we have busybox. Now you might be asking yourself, what is busybox? Busybox is almost like a bash terminal. It has a lot of the same kind of bash utilities, such as changing a directory or ls the files that are in that directory. but it's minimal. So it's basically all those programs rewritten into like the smallest size possible. As you can see, we've got an entire terminal shell for 1.24 megs there. And what we're going to do now is we're going to run, say Docker run busybox. In this case, I'm going to actually give it a name. So I'm going to do -n for my busybox. Let's see. And apparently that's not right. I think I have to actually put the -n in front. Let's see. We'll just do --name. I know that should work. So my busybox. Oh, okay. So basically just ended. And you might be asking yourself, well, why did that go? If I do a Docker PS, nothing's running. And if I do a -a for all, I see that my busybox was there. There's that one that I messed up on that, which this is actually really good. But by default, busybox, when you run it, it's looking for command line arguments passed to it after the image of it. So one thing we could do is we could say run, and I'm going to take say -2 there. So because each time we run our run command, we're essentially starting and creating a new container off of the image. And I'm just going to say echo hello from busybox, and we run that, and we essentially now console that out there. So again, we look at Docker PSA, and we see we have busybox and busybox2, so that's all great and stuff. But you might be asking yourself, well, that's not very helpful to have to keep on creating these images and stuff, and you would be right. One thing that we can do that's kind of neat is we can start an image that has been stopped. So this image basically ran, it executed, it had a command there of the hello busybox, but once it's done, it's set up to not restart itself, and that's a configuration that you can actually change to have it so that maybe if it crashed or if it exited, you can say restart yourself. But if we wanted to, we could say Docker start instead of run my busybox 2, and we start that again, and I think it looks like it doesn't start the command again, so that's really interesting. But what I really wanted to show was if we say Docker run, we can actually do a -it for interactive terminal, and say Docker run -it, and we can give it a name or whatnot, or just leave it off and it'll generate a random one, and we'll say busybox. And when we run that, now we're actually in some sort of terminal. If we actually look at the files there, there's my operating system that's running. It's the minimal container that we have in there. If I go to home and do an ls, there's nothing in there. So this is kind of interesting. What happens if we created a file in here? If we do touch test.txt, there's now a file in there called test.txt. What do you think will happen if I exit it and look at our Docker container? So Docker container ps-a, I see that this is the one that just was created and exited 7 seconds ago. If I ran that same command, run interactive, do you think I will see that file in there? Well, let's try it. If I run that same command, and if I do an ls and I go into home, there's nothing in there. And the reason, like we've been talking about, is each time you run, you get a self-contained container, for lack of better words, that will be, again, a copy of that original image and be out here. So if we say Docker ps -a, you can see we got this beautiful Golik one right there. Now let's try it. Let's see if we can go and start this guy again. I'm not 100% sure, but let's try starting him, focused, and let's see if we can start with an interactive terminal. I don't think we can. And so in that case, it's in there, it's gone, and it's running. So BusyBox is obviously not a super useful one. Let's go ahead and try something a little bit more interesting. And this is where kind of really the power of Docker is at. Let's say I want to set up a database real quick. And so MariaDB might be our database of choice. And so I'm going to do a Docker run. And so -D would be disconnected. And so essentially this will run it, and it won't spit out stuff to my terminal. It'll just be kind of running continuously in the background. I'm going to give it a name of my MariaDB. And so here's something that's kind of interesting. You can pass environment variables to Docker with a -E command. So I'm going to pass it a MariaDB root password. So this would be the password I want root to have by default when it starts up. I'm just going to say test, and I'm just going to ask for MariaDB. And what you can do is you can do a colon. You can ask for certain versions. Let's say you know that you don't want to go all the way to the latest, which might be 10.3. You might want like 8.3. You could ask for that version of it, or you can just honestly ask for the latest version of it. Click enter. It can't find the image because I don't have that images down there. So now it's downloading all the different layers that create that Docker container that's in there. This one's obviously a little bit bigger with 80 meg type layers to them and stuff. But essentially it downloaded, and it says it's finished. If we go to our Docker containers that we have here, we can see my MariaDB is up there, it's running. We can see all those other ones that have exited. You can obviously click and remove them from here in this utility instead of doing it from the command line, and do all that stuff. But so MariaDB is running now, and it's persistent. So if I do a Docker PS, you can see right there MariaDB is running. It's been up for 31 seconds, and it's got a port 3306 there. One thing we can do is we can look at the log. So as MariaDB is running, it's spitting out kind of console logs, and you can actually inspect those or view those with the logs command, and then you give it the name of the container. So Docker logs MariaDB, my Maria, and here's kind of some of the outputs in there and stuff. So that's kind of cool. One other thing you can do is you can obviously view those in the Docker desktop. You can click on my MariaDB, and after a second here, it'll pull in those logs. So you can kind of see the same stuff that I looked up there. You can inspect and see, I see there's an environment variable in there, the path where it's at. We're going to cover in a future lesson kind of some of what mounts mean, but it's essentially a way for you to actually have persistent storage that can save across maybe containers. If you were to update your container or remove your container, the volume will still persist. And so just kind of real quick go over that. You can see right here we had containers, images, and we actually have volumes. And so by default, MariaDB generated a 148 megabyte volume where it can shove all of the database data that you can kind of get to and stuff. But like I said, again, we'll cover that in kind of a future. And then we have port 3306. We can kind of look at some of the stats of it, how much CPU usage it's using, all that fun stuff. Again, everything you can do in the desktop, you can do in the command line, because that's honestly where it first was created. So you can say Docker inspect, and you can say my MariaDB. Come on, tab complete. So, all right, there we go. So all that kind of same stuff, plus a whole bunch more, is in here. So you've got your state that it's running. You have the restarting is false, so it won't restart itself. When lot of other things in here, but we would have, there's that volume mount that we have, the environment variables that were passed to it. So obviously this would not be a super safe way of passing passwords. If somebody that was able to get onto your system was able to run this command, they can see, hey, it's there's your password right there. Anyways, but that, again, that's the initial password. You can go into it, and that's actually what we're going to do right now. So we're going to actually try to connect to it. So your first guess might be like, hey, I've got this thing running. It's running on my computer at port 3306. So I'm just going to use my command line tool, mysql-u root-p, and I hit enter and I type test, and well, could not connect. And so by default, MySQL, when you use the command line tool, will try to connect to it via a local socket. So that didn't work. Let's see, what if I tried -h for host 127.0.0.1, and I try that, and I type in my password. Nope, could not connect there either. Well, that's interesting. So I'm just going to kind of cut to the chase. The reason why that doesn't work is because we did not map the port that is inside that Docker container to anywhere outside of that Docker container. If we come here to the inspect and we go down the port, we see that 3306 is there, but it's not bound externally to that container. So you might be asking yourself, well, why would you want to do that? Again, in a future lesson, we'll talk about how you can create a network that only containers themselves can communicate through. And so you might have a container that's running a node process that's connected to a container that's running MariaDB, and it doesn't allow any external access for maybe security reasons and such. So you might want to not expose that port to the host system in that case. But there is a trick that you can do if you want to actually get into that. Say you didn't bind that port and you purposely didn't want to. And that is, in the case of where this Docker container is running, we can actually execute extra commands that are already in that container. And so we're going to do kind of like we did before, where we're going to say Docker, but we're going to say execute a command. Instead of running a container, which will start up a new one, we're going to execute a command in a container that is already running. And so we're going to say execute interactive terminal, and we're going to say my MariaDB, and tab was a poor choice to hit that time again. MariaDB, and I'm just going to say I want to run the command bash in there. I do that, and so now I'm actually in a terminal inside the Docker container. And so I can do ls, and I can see here the file system is typically in MariaDB it's var, I think it lib mysql. There's all of your buffers, and your different databases are usually subfolders and stuff like that. So I'm actually in this container kind of messing around in the files that are here. But with this container that MariaDB made, they actually put the MySQL command in there. So I can say MySQL user root -p and give it a password test, and now I'm in. And I can show databases and do all the stuff that I would normally do. Select users from MySQL kind of thing. Select star. Use MySQL, and then select user from something like that. Well, anyways, show tables. You can essentially see that we have all that stuff in there. Select star from user. That's what it was. There we go. But I digress. You can actually leave the container by typing exit, and now we're back into my host machine. But let's say you did actually want to expose that port out. How would you do that? Well, I'm just going to do a docker ps, and I'm going to say docker stop my MariaDB, and basically just kind of stop this thing, and then I'm going to really blow it away. It doesn't really matter a whole lot. I didn't really do a whole lot of work there and stuff. And we'll talk in the future if you wanted to blow away a container but leave the database as files there, we'd have something, use those volume mounts to kind of do the same. So I'm going to do a, just for fun, Docker rm my MariaDB, and then I'm going to hit Control R and go kind of a backward search, and I'm going to search for Docker run, and I have my entire command there. Just hit the right on the keyboard and do a -p. So for a port, I want to expose 3306, and I'm going to expose it to the same port on my computer, 3306. So it's just kind of mapped the same. Hit enter. Since that image was already downloaded, it starts up really fast, and we can kind of see it's already kind of running. We can look at the logs of my MariaDB, and there it's up, it's going, it's ready to be connected to. And so now again, I'm going to try to connect to this. I'm going to do a MySQL. Let's see if this guy works. Test, and I am in it. So now I can access it from my host system, or if I have my firewall enabled, I could access it from outside of Ubuntu altogether. But again, I hope this was a good kind of introduction, and we're going to have lots of kind of follow-on videos for Docker on all the kind of the amazing things you can do with it. It makes, like I said, self-contained applications really awesome and really easy to work with. We're going to be moving a lot of our infrastructure on our servers to using Docker. We already have. We've used Dockerized containers for Redis, for MariaDB, and in fact, Galera, which is a clustering software on top of MariaDB. We've used it for MongoDB, and we'll start using it for our Node application. So I hope you'll take the time to actually learn and embrace Docker. Everybody should be able to get one up and going, especially if you're a Windows user using Windows subsystem for Linux. And I hope you found this useful. Thanks.